Hi, it's Moser with a quick tutorial on drawing Lewis structures for compounds that contain a double or triple bond. Gasp! So after watching this video, you should be able to draw the Lewis structure for any compound or polyatomic ion which contains a double or triple bond. In order to do this, you already need to know how to draw Lewis structures for basic molecules and polyatomic ions using the octet valence math method, sometimes called the Mr. Gooch math. Okay, let's go. Okay, we're going to start with good old CO2, carbon dioxide. And this seems like a relatively straightforward molecular compound. 3 atoms, fantastic. We're going to go ahead and draw the Lewis dot diagrams for carbon and for oxygen. And I'm going to jot down how many of each atom I've got. Then I'm going to figure out the number of valence electrons. So coming into it, this CO2 has got 16 valence electrons. Now, if I look at how many electrons CO2 needs to be satisfied, that gives me 24. So taking the number of octet electrons, what it requires to be satisfied, and subtracting the number of valence electrons will show me how many electrons are going to be shared. Okay, we're going to share 8 electrons between these 3 atoms. Well, when I divide my number of shared electrons by 2, that gives me the number of bonds, which in this case is 4. That's weird. So I'm going to go ahead and calculate my unshared electrons too while I'm at it. And that tells me that with the 16 valence electrons that these things bring in and the 8 they're sharing, there will be 8 valence electrons which are not shared in any way. Okay. Well, look at that. What do I have? I have 4 bonds. Well, remember, carbon is in the middle because carbon, or the least electronegative element, is always in the middle. And we have carbon. We've got it double bound on each side to oxygen, meaning they're sharing 2 pairs of electrons. And oxygen has still got these guys, these unshared pairs that it came in with. Now, what are the normal checks we run? Well, we want to make sure that we have the correct number of valence electrons. So we're looking to count 16 valence electrons here. 2, 4, 6, 8, 10, 12, 14, 16. Okay, we're good. Now we want to make sure that every atom in this Lewis structure is satisfied from an octet perspective. So this carbon feels like it's surrounded by 2, 4, 6, 8. Carbon's happy. This oxygen feels like it's surrounded by 2, 4, 6, 8. That one's happy. 2, 4, 6, 8. That one's happy. So guess what? We have a correct structure for CO2. So I'll mention at this point that when I learned to draw these, I was taught all kinds of ridiculous stuff like, well, we take this over here and we put it there, and then we have to move this electron over there, and then this other one from here moves over there. That's crazy stuff. I mean, it's more or less the way it happens, but it goes back to people getting way too hung up on these individual little black dots, which, remember, are not actual electrons. They're things we use to represent electrons. And, you know, yeah, we can move them all over the place, but I think it makes a lot more sense to mathematically figure out how many bonds we're looking for and how many unshared electrons we're looking for. Yeah? So let's do one more, and let's get all crazy. You'll see. Okay, so this HCN is actually cyanic acid. Whoa! Like cyanide? Yeah, like cyanide. So I've gone ahead and I've drawn out the Lewis dot diagrams for the elements going in. I have forgotten an electron on nitrogen. I'll fix that a little bit later. And I've listed how many atoms of each type I've got. So I'll get my valence figured and my octet numbers figured, what these would take to be satisfied. And I find that these are coming in with 10 valence electrons, and I've got 18 octet electrons. Okay, so subtracting valence from octet will show me the number of electrons shared, which in this case is 8. Well, dividing my number of shared by 2 gives me the number of bonds, and I find that this compound is going to show 4 bonds. And it's that's going to have 2 unshared electrons. Let me fix my nitrogen right now. So we know that carbon, if it's present, is always in the center, carbon or the least electronegative element. And since we've only got 2 things to sort of hook up, we know it must look something like this. We also know that hydrogen can only bond once. Well, that takes care of 1 bond. Where do the other 3? Oh dear. 1, 2, 3. Nitrogen is well known for bonding 3 times. Carbon's also very capable of bonding 3 times and commonly bonds 3 times. So that gives us our 4 bonds. That's pretty easy. And our 2 unshared pairs, well, if we look at nitrogen to start out with, it had those 2 paired electrons. So we stick that there. That's it. Again, you can do all kinds of funky stuff with moving dots around, but remember, those dots aren't electrons. They're things that we use to represent them. They happen to do a really good job representing them. But in the end, you need to think mathematically about how many bonds you should be showing and how many unshared electrons there should be. Okay, get some practice on double and triple bonded compounds and come back when you're ready to look at resonance structures in our next video.